All right. So, hello everyone. Welcome to the CharIN Tuesday Europe Part 3 today about our most important topic, I guess, in CharIN. So the CCS certification scheme and automated conformance testing. So happy to have you here. And I'm wishing you a interesting Tuesday. And if you have questions, meanwhile, you can send them with the chat function of GoToWebinar, and we will pass them to the panelists afterwards. And now I'm happy to hand over to Johan Sjöstedt, and we can switch the slides. So see you. Bye-bye.
Thank you so much, Ricardo. I would like to welcome all of you to the focus group interoperability and conformance testing. And I want to start a little bit with talking about electrification and the main enablers for hybrid or for plug-in hybrids. That was affordable high voltage batteries. But for pure electrical vehicles, the true enabler is to have a working charging infrastructure. That's why this group were created, and that's why so many different companies are working together to try to give the customers a smooth charging experience while using a CCS device. If we shift the PowerPoint slide, one more slide, please. So this is the group. I'm up to the left corner. We have Lars Beck as the deputy, and he is also working with the development team. We have Wujan, who works with qualification, and he's from KERI, and Beat Kreuter from DEKRA, who also works within the qualification team. And we have Jan Grossman from Vector, who's worked with team vendors. The main thing with getting working charging infrastructure is the interoperability between the electrical vehicle, the EV, and EV EVSE. Just to make it a little bit clear, when the EV EVSE, that means electrical vehicle supply equipment. And that basically means both an AC charging cable, it can mean a wall box, or it can mean a DC charging station. And electrical vehicles is it's the car. So if you look on the right part of this slide, this is the composition of a group. Within the entire charging ecosystems, we have people from OEMs, which is the vehicle manufacturers. We have from the charge point operators. We have from the grid operators. We have some. And we have from the e-mobility service providers. We have the charge cables, and we have the EVSE, which is the charging station as well. So in total, we have 204 members and 85 companies. And if we go back one slide, please. So I will show you the agenda. The team will different leaders here will talk you through and give you a much more detailed explanation than I just did on how we will go, how we will move towards our working charging infrastructure and a smooth user experience as possible for all customers using CCS. So we will start with Wujan Zhu from KERI to look in the quality assurance plan for conformance testing. After that, we will look in the test and certification with Beat Kreuter from DEKRA. We will look in for the CharIN CCS certification scheme and automated conformance testing with Michael Tubel from Keysight. And then we will round off the day with a panel discussion and some Q&A. So I just will end with saying welcome everyone and leave over to Wujan.
Okay, yeah, let's start the first session of this presentation or this seminar. That I'm Woo-Hyun from KERI, and I'm responsible for the conformance testing. First of all, I'm really pleased to having me that as a first presenter. Actually, we have developed and established this process for last 3 and 4 years. So now we have providing some testing services with the two testing houses as well as three CCS vendors. Okay, today for last 15 minutes, I'm going to introduce this process firstly as a very smooth starting of this seminar. Please go on the next page. Before introducing this process, I have to actually, this is quite necessary, the step to explain about how the charging is going on as a behaviors. So first of all, the charging station will provide this the energy from the grid to the battery in the electric vehicle. First of all, this AC, the grid, the electricity could be converted to the DC, and then voltage could be this flexible to fit after the voltage of the BMS or the battery, and then communication could be a ping pong pattern that based on the request from the EV side, as the EV EVSE, and then response always could be made by the charging station. Based on those of their behaviors, charging could be successfully done. You can see this below graph. The SOC will be going up, and the voltage is very slightly going up as well. And then current could be made upon this request of the EV. Based on this structure, inevitably the DC converter makes some noise, so sometimes it makes some issues to interrupt charging sequences. And then based on also with those of the principle, we have to realize two kinds of the interoperability are very important. First of all, physical interoperability. Actually, if you apply the CCS system, this physical interoperability or the inlet and connect coupler that have been made on the interoperability firstly. But the problem is charging pattern. Standard only say the specifying with the behaviors between the EV and EVSE, it doesn't describe not to do. Those of this basic the principle, we might have some issues between the different interpretation between the EV and EVSE manufacturers. That is a basic the reason to make some issues occurs or issues in the field of the charging station or electric vehicle. Please go on the next page. So due to some interoperability, we might meet or face some kind of the failures of the charging. First of all, the unexpected charging start failure. If you plug in some charger or EV cannot start charging. Otherwise, or the not intended charging stop, or sporadic the charging stop happen in the field. Also, some of the not unplugging after charging stop could be experience, could be happen in your EV and in EVSE. So after charging, the voltage should be under 60 volt, but sometimes it couldn't get under 60 volt. So EV will hold your connector. At the moment, we have to get more and more EV time models in the market. We expected more than 300 EV models and then 3,000 EV models in the global market. So more the market sizes will make this more interoperability issues. So users will have some very bad experience, kind of the longer charging time, uncomfortable charging experience, and then charging failure. So what you're gonna do, we have to give some of the great resolution on upon these interoperability issues. Please go on the next page. In order to figure out or to resolve those of the interoperability issues, we can approach two kind of the different directions. First of all, we can apply some of the interoperability testing. We get together in the one spot from the EVSE manufacturers and then EV OEMs. We can start some testing between the EV and EVSE. Theoretically, it seems to be very perfect, but in the real field, at the moment, we will have, or some manufacturer is going to develop their own time models, so we can do every EVSE and then EV models in the one spot, theoretically, and then so in the growing market, it is not feasible. But the conformance testing we can apply with some norm is as a testing system. So EV SE and then EV can get some conformance testing against the norms, the testing system in the lab. So you can perform and execute in the test cases and the test at any time, at anywhere, if you have some localized testing houses or some recognized testing houses by some certain level of the process. So in the growing market, it's a more feasible, more scalable approach is conformance testing. Please go on the next page. Yeah, in this page, I just introduce kind of the first approach in the testable event. Even though I just speak up the interoperability testing event could be this just a part of or have this some problem or not a problem is it's not feasible in the growing market, but this is quite important because we to reduce or to apply a new standard at the first beginning stage, we have to get some of the very small size of the testing is very useful to figure out some issues or these test cases or requirement from the standard could be this useful or is not the makes it not a problem. So in the CharIN testable in the three different continents have been held and then planned in the next year. Yeah, we will have the 3 different testable. So in this picture, you can see some of the already taken place the event in the Europe, or that you will have you will participate this North America event, something like that. So you can see their pictures, and then if you are interested in this event, please contact the CharIN coordination office. Please go on the next page. As I told you right before, I just introduced the CharIN Asia Testable. It's hosted by KERI. You can see this presentation file. Please go on the next page. In this page, I'd like to explain why we have to get this one global process. I just describe the depict only in terms of the Korea, that actually we have some infrastructure or the charging system with the different companies, OEMs, and then EVSE manufacturers. So even though we organize or we establish some Korean local side, the technical guideline or IOP certification for the conformance testing, no one knows, and then actually the Korean certification system cannot fit or give some very great guideline to everywhere. So and then some localized, the people or the localized agency would like to make their own process and about the conformance testing in terms of the interoperability. It will be a very nightmare. For example, North America, some government or the US government would like to make their own the interoperability certifying the process, and then Europe as well, and then Korea, they have their own certification for interoperability. In some of the interpretation might be the different, so testing could be executed differently. In the field, interoperability issues will not disappear forever. So we have to get this one global and then integrated this process for global interoperability. Go on the next page. So CharIN focus group conformance testing and the interoperability. We have been working on some process, establishing some process into the CharIN, and then as a one global process. We have the 3 different teams. Already Johan introduced you about the team, and so I'm going to skip in this page. Go on the next page. In order for the people to understand easily in this group that propose 3 different steps in the STEM models. The first of all is a CCS basic, and then the other one is a CCS extended, and the final step is a CCS advanced. For the understanding easily, I just can explain with the international standard. First step is directly connect to the DIN spec 170121, and then basic features is a technical feature that will be covered by the DIN specs specification. So this is a basic charging or the high rating of the charging, like that. And then CCS extended is coupled to the ISO 15118-2 part 2. So it will provide the certification or the testing with the plug and charge and the secure charge and the smart charging, something like that. And the final step is come up with the ISO 15118 part 20. It covers in the wireless power transfer and then ACD and then bi-directional power transfer, something like that. So for the people, we describe this composition of the different standard is quite complicated. So we just name enabling and the basic, extended, and advanced. Go on the next page. In order to make some great process, we thought 3 different parts are necessary and mandatory. First of all, we have to develop the specification to integrate and to consolidate or just make some addition from the original standard. So as I told you right before, we make the 3 steps and then EV EVSE. So to consolidate the standard requirement, we developed some test cases, or some test cases have been migrated from their standard. So first of all, specification is quite important. The other one is testing system. Testing system will give some great test report and the test widget with the automated concept. But those of the test system have to give consistent test widget and the verdict. So we have to validate those of the testing system implemented by the test cases, implemented by, with the test cases. Final thing is testing house's quality is a competence. Even if the testing system can give some consistent interpretation or testing verdict, testing house can make some different the decisions for the testing. So 3 steps is specification and the CCTS or the testing system's consistent verdict and the test result. And then final is a testing houses, a same interpretation and then competence. With those of the three resources and the steps, we can make some great process and as a certification into the great global market, and then final user have very happy the charging experience. We spent 3 years and then 5 months. We have to figure out and then get some resolution about against some issues inside of this process. So you can see the timeline that finally in this year, July and the 26th, we have this three different validated CCTS vendors and then 2 recognized testing houses. Go on the next page. Yeah, this is example why we took the 3 years and 5 months. We executed 230 test cases, but it was a kind of the very awful result. Almost 30% of the test result have been inconsistent. So we did again and again, and then improve the test cases itself, and then give some another implementation of the test cases inside of the testing system, something like that. And then we in this year, this July, we finally get a consistent verdict and then consistent result by testing houses. Go on the next page. All conformance testing should be executed according to your umbrella document. If you take a look, you can see this every test cases list or from the different standard and as a references. So total number of the test cases 170 or 71, almost 60 or the 60 test cases is migrated or coming from the DINSPEC itself. The other 72 test cases have been edited from the original standard, or some improved test cases have been developed. Yes, it's and then test 1 and test 22 test cases we developed, and then almost 38 one EMC testing. So final target is we will provide the highest quality of the interoperability testing services as based on the CharIN global process. Go on the next page. Please go on the next page. Yes, yes, go on the previous page. Sorry. Yeah, this is a future plan. We will develop new specification. We will do this CCTS validation again, and then we will get some assessment for to check the testing house's competence in the future. It will follow the step of the standard development, and then in the future we will establish new step like the extended and advanced in this year or in the next year, and then after next year. Okay, please go on the next page. Yeah, this is the end of my presentation, and then we are discussing the which step or which part is actually we started just a step of the CCS basic EVSE DC. So maybe in the next step there might be this EV side or the EV CCS extended EVSE, something like that. So please participate this group and then give some your opinion and voice. Okay, thank you for listening my presentation.
Okay, thank you, Mohan, for let's say your presentation. Well, what I'm going to do the next couple of minutes is to give you some more background, let's say, on the testing part, and of course also on the certification part. Next slide, please. Yeah, okay. I think we can also skip that to save a bit time there. That's basically what we are discussing. Next slide. One of the big questions, of course, always is why do we need to do interoperability and conformance testing? Well, I think at the end, it's a very simple thing to say that more and more electric cars will come onto the market, depending on what you look at, on which, let's say, market research or which statistic. The expectation is that in about 10 years or in 9 years, there is anything between, let's say, 30 million to 130 million electric vehicles on the road worldwide, of course. And we are certainly also aware that in most economies up to now, except a few, of course, we have, let's say, one favorite charging standard, which is the CCS standard. There are differences with regards to the plug. When we talk about CCS, so we have CCS1, which is mainly used in North America, and I think also Korea, and CCS2, which is then being used in the rest of the world. So one thing becomes clear when we have so many electric cars, we of course need to have a huge amount of charging stations at home, but more importantly, of course, also along the major freeways and roads. Next slide, please. So when we look at this picture again, maybe right now we do have a few electric cars which are really sold on the market, but even during 2021 and 2022, of course, we are expecting more and more electric vehicles being placed on the market. So this is just a very small snapshot. And when you reflect back on what has been shown before during the presentation, then certainly you can see the more electric vehicles are on the market, different type of electric vehicles are on the market, and the more charging stations are on the market, potentially the more critical becomes, let's say, the interoperability aspect and the conformance aspect. Next slide, please. Yeah, this one here again, I think we have already seen, so we can skip that. Maybe just to mention, we are still at, let's say, basic EVSE 1. The explanations have already been given from, yeah, next slide, please. Explanations have already been given by Oyun about, let's say, the program development. I think what I would like to point out here again is that, of course, we have had many people involved in developing, let's say, the basic certification program for DC charging station. So the CharIN basic certification program that included the vendors, I mean, test equipment manufacturers, that of course include people like myself and Oyun, coming from testing labs, having a tremendous amount of experience on how to develop testing processes, but also how to develop certification process, including, of course, everything is what is around to ensure that when testing is being executed, that you have a high level of repeatability and quality. But more importantly, of course, we have had to have the specification. That basically, that part has been taken up by the development team, which also consisted of experts from EV EVSE manufacturers, from EV OEMs, and of course from many other interested stakeholders. The outcome was basically that we had, let's say, an agreed amount of test cases. So that again were these 170, roughly 170 test cases, as we have seen just a couple of slides before. We have clear processes in place, and we have also validated test systems in place. And when we mix that all together, of course, then we are basically able to execute conformance testing, and of course also interoperability testing. And at the end of the day, that would actually really help to make sure that all these cars, which we have seen before, or let's say 135 million cars by 2030, that they are actually able to charge when they really need charge. Next slide, please. I think we also discussed this one already, so maybe skip that one. Yeah, and of course, the CharIN certification program has been published a couple of weeks ago already, and one of the major manufacturers of charging station is already, let's say, in the process to obtain the first CharIN CCS certification for the DC charger portfolio. So that is in process. Next slide, please. And here I would like to reflect a little bit why interoperability and conformance testing, of course, is important. I mean, when you do, let's say, testing of charging station, of course, you see many different things. What can happen? Charging stations which behave sometimes a bit different than what's basically expected. What or the reason why they are behaving differently. Well, either it is not clearly explained in standard how they should behave, or of course the interpretation of the requirements is slightly different between, for example, different charging station manufacturers. What we see here is a good example. That's during the validation process. So basically the EV EVSE in this case has confirmed that it has seen two toggles. But after it has seen those two toggles, it basically drops the PWM signal to 100%. That basically means the charging process at the end still doesn't really start. And if you have bad luck and you are not actually being notified as a user that the charging is not going to continue, you may go and wanted to drink something, because that typically happens right at the beginning. And of course, if you have something like, for example, plug and charge, then may just simply your car will not charge. So luckily, in some cases, the car might send a notification that the charging process has been interrupted, but that indeed does not always happen. Okay, so that is just an example. Of course, there are more examples. Next slide, please. It's not always about interoperability. Sometimes it's indeed also about safety. So what we basically see here is that initiated emergency shutdown by the electric vehicle took quite some excuse me, took quite some long to be executed. There is a clear time described inside the standard that should not be longer than, for example, 40 milliseconds. But here in this example, it is more than 100 milliseconds before actually the EV EVSE did shut down the current and drop down the voltage to an acceptable level. So that, in fact, could, of course, cause some safety hazard, or even cause some damage to potentially the battery or other parts of the car electronic. That again points out why it is important to do, for example, conformance testing, just simply to make sure that the charging station does comply with all the specific requirements as outlined in the standards. Next slide, please. Here again, we have a good example. The electric vehicle does actually send wrong charge parameter. If this is the case, or if that happens, typically the charger should stop communicating, or should drop the communication, or at least send, for example, the electric vehicle that there is something wrong with the charge parameter. So in this case, actually, that did not happen, and the charger continued to process the charging sequence. And of course, that could then again potentially create hazards to the electric vehicle. And things like that, of course, should not happen. And that is again another reason why, for example, conformance testing is so important, to make sure that not only, let's say, the interoperability aspects, but also the safety aspects are being complied with. Next slide. Yeah, here also another example, which is maybe more, it's not really safety relevant, but it's again a kind of like an interoperability issue. That the EV EVSE in this case has not restarted the communication. Also, the electric vehicle has indicated with a state B that it is actually there. and also the PLC link and the TCP link were not actually dropped, but the charger just simply didn't start up the communication anymore. And that again could mean, for example, that the EV user might not be notified that the charging session actually has stopped, and then he probably should go back again to restart that charging session. So that does at least not create a safety hazard, but of course it's a tremendous inconvenience for, let's say, the EV user. So I'm pointing out again why it is important to do interoperability and conformance testing. Good, next slide. So there is this so-called umbrella document which has been published in July 2021. That's the CCS Basic DC EVSE conformance tests. And that document basically outlines exactly what has to be tested in order to obtain a CharIN certification for a charging station. The document itself does make references to a lot of standards which are typically being used for testing charging stations. Of course, we just mentioned it before, it's not only about interoperability, but it's also about, for example, maintaining the charger to be safe when something happens. And that's the reason why, for example, IEC 61851-1 edition 3 is referenced there. Of course, also IEC 61851-23 for DC chargers, which takes elements out of the edition 1, but also takes into account elements and requirements which are then going to be in the future edition 2. What also happened is those standards, especially the -23, of course, has so-called gaps, unclear requirements. Those unclear requirements have actually been defined as part of the CharIN work, and they are being described in that so-called implementation guide for System C, which is at the current version 1.2a. Communication requirements are taken out of DIN Spec 7121, and also there are, let's say, interpretation issues. There are maybe requirements which are not quite clearly being described, and also those have been sorted out as far as possible. Those requirements have been put down in the CharIN implementation guide to the DIN Spec 7121, which is currently at the version 0.95. Now, for the testing itself, of course, we refer then to the DIN Spec 7122, and of course, in order to test those additional requirements coming from the CharIN implementation guide, CharIN also has established another document, which is the CharIN test cases for the DIN Spec 7121, which makes sure that all the requirements which are defined in the implementation guide are then appropriately tested. And we also, of course, have a reference to the vehicle coupler testing, which will come in the future. Right now, the vehicle coupler testing is not actually required, but it is needed to provide sufficient document to see that the vehicle coupler is appropriately tested already and based on its own standard, in this case IEC 62196 series. And also one of the reference documents is the CharIN DC CCS power classes version 6, which then outlines the different power classes and what kind of specification they should fulfill, as for example the maximum current which is expected, the maximum voltage is expected in order to achieve a certain power class. Power classes at the moment, or the most important, let's say, power class, or the highest power class, maybe to put it in that way, is, for example, the HPC high power charging 350 kilowatt. So all those requirements are outlined in that CharIN conformance test for DC CCS Basic EVSE. So go to the next slide, please. When we look into the details, then again, we have seen that already in the previous slide. So we have about 9 test cases which are derived from IEC 61851-1. They focus on the control pilot and on the proximity pilot. So that's the very basic what is actually being tested. And of course, what is being tested there is whether we are, let's say, having the right frequencies, whether the duty cycles are okay, whether the voltage levels are okay, and of course the tolerances. And that actually is being done, for example, on the maximum load condition, on the minimum load condition, just to ensure that the charger does not change, let's say, the frequency when it is running or operating at maximum load, or when it is operating at minimum load. And the same applies for, let's say, the voltages, the voltage levels for the control pilot. They are being tested at the maximum load and minimum load. Next slide. Yep. Then we have 29 test cases which are being derived from IEC 61851-23. Of course, they also focus on control pilot to a large degree. They also take into account the proximity pilot, but more importantly, it is about, let's say, the high voltage and the high power part. And of course, it also includes the high level communication, since DC charger will not work without without high level communication. Typical parameters which are being tested is, let's say, the behavior on short circuit, protection against overvoltages. Then, of course, we have test scenarios which deal with interruption of the control pilot, proximity pilot, what happened there and how the charger is responding. Then we have test cases around the load dump and most importantly, the charging performance. So it's really to make sure that the charger is able to deliver what is claimed, so that the 350 kilowatt charger actually can deliver the 350 kilowatt. We also look at the pre-charge voltage levels, at the accuracy of those voltage levels. Then there are several test cases which are checking the insulation monitoring for valid and error. So that means if there is an insulation fault detected, whether the charger is accordingly shutting down within the appropriate amount of time. Emergency shutdowns, which can happen, are being tested there. Then we have test cases which are dealing with charging reliability. So that's, for example, how the charger behaves if it is being exposed to several charging cycles, one after another. It means if 20 cars come and each of them wants to charge, whether the charger is actually able to do that. We also have reverse power flow test cases. And of course, we have test cases which assess the power class. So it's quite comprehensive, but it gives them a good picture, not only about, let's say, communication, but also about the technical readiness of those chargers, and of course also the quality of the chargers. Next slide. There are 59 test cases which are coming out of the DIN 7122. Those test cases, of course, are mainly here to ensure that the V2G communication is doing the appropriate thing, that the parameters which are being exchanged are in line with what is mentioned in the standard. Only, of course, if we have an agreement between the EV side and EV EVSE side, we have successful charging process from the beginning, starting from the slack match process up to terminating the process and unlocking and unplugging the car. Next slide. As already said, there is this CharIN implementation guide. So 72 test cases have been derived from the CharIN implementation guide. So the test cases for the CharIN implementation guide, they essentially deal with the same. So the entire charging process is covered there, starting from the slack match process towards ISO interoperability test cases, charging reliability test cases, charging robustness test cases, and of course at the end again unlock and unplug, whether that process is appropriately being executed. Okay, next slide. And we have two special CharIN specials. So one of them is related to EMC, that is to make sure that the radio disturbances are limited on the control pilot. Generally, if you're in compliance with 61851-21-2, that isn't really a problem. And we have that upcoming connector interoperability test, which will then look at establish appropriate locking, incorrect inserting, so means fault cases, maintain the locking and the unlocking. But that connector interoperability at the moment, as said, is under consideration. Next slide. That's generally how it looks like when testing is being performed, but I believe Michael Teibel from Keysight will provide some more info on that. So next slide. And that is how a test certificate is looking like, which is then being issued based on the testing against those CharIN requirements. So that will be then a CharIN, let's say, test certificate, which will be handed over to the applicant, including, of course, all the supporting documents and reports which are needed. Next slide. And again, why do we do that? Well, that is just simply to make sure that the EV user actually has a happy charging experience and not an unhappy charging experience, which unfortunately is still happening too often. And I think the entire industry has to make sure that we really go towards the direction that all customers, regardless what kind of car they have, regardless where they are going to charge, that they have a happy charging experience. Next slide. There is one thing what we always have to mention when we talk about CharIN, and that are the regulatory requirements. CharIN is on top of all the regulatory requirements and of course does not replace regulatory requirements. And the regulatory requirements, for example, for safety and for EMC, they might be slightly different. Also, the technology is still the same. CCS technology is used worldwide, but regulatory requirements might be slightly different. Next slide. And here, just to give an example, because CCS is used in, let's say, in major international markets, but it is also being used in the United States. And many of the standards are slightly different, especially when we discuss about the safety. You will see the difference that for international aspects, it's all based on IEC 61851 series, whereas in the United States or in North America, different standards are going to be used for the regulatory aspects, so namely for the safety aspects, but also for the EMC aspects. I think that was the last slide, but yeah, go to the next slide and let's see. Yeah, thank you very much, and looking forward to receive some more questions during the Q&A.
Thank you so much, Bert. I think we have some questions in between here. So we have this quick poll. I forgot to say that before, but here we want the audience to be a little. You have a chance to give some input to us. So yeah, we know a little bit what you think, and yeah, then we can take into the group and discuss it. So please answer these questions. We will look at it together with the entire group later. And then over to you, Michael.
All right. Thank you, Johan.
Yep.
So, am I able to control the slides?
No, you just have to say when you want to change.
So what about now? Next slide, please. Okay, thank you. I would suggest, as we are running out of time a little bit, to skip a few of the introduction slides. I believe these will be shared by CharIN anyway, so you will see this later. Yes, let's please go ahead. don't want to bore you with our history. Let's continue, please. Okay, next slide. Yes. So I don't want to repeat what especially Beat and Voyun already explained to you. The whole motivation why we have been in working groups working for quite significant amount of time on this topic is, if you please click once or twice to open up the slide entirely, and then, yes, thanks, that's it. So if you look into the really, let's say, fundamental standards behind CCS charging, you will see that especially on system level, there are no real test specification included inside the IEC 61851-1 and -23, which particularly are relevant here for the EVSE certification. And also, if you look into the conformance test cases for communication, you will see that these mostly are kind of outdated because the edition 1 standards are already 5, 6, or even 7 years old. And so there is a lot of work to be done in order to be state of the art, as all the products on the market have developed meanwhile. So I believe that this effort was absolutely essential, and that the specification that is now provided by CharIN is really very important to fill this gap. Let's please move on. Now, you have seen these documents before. I just want to point out, before we look into the actual implementation and what is behind it, again, if you look for these documents, you will need basically these 3 documents. One is an umbrella document, one is dedicated to -1 and then -23 test cases in the middle, and then there is a dedicated implementation guide which contains the protocol conformance test cases based on DIN spec 71-1. Next slide, please. Now, as probably not all of you want to implement all specifications on your own, we have been working for some years now on implementing an automated test tool which is able to execute these test cases. And let's please go to the next slide. Thank you. And when doing this, we work together with other vendors in the CharIN vendor team to define a common architecture, how to implement these test tools. This is very important because, for one, many customers will and developers will need to really use a different test setup, as some maybe want to use these kind of test tools during R&D, during initial implementation of hardware components and software. And then, of course, at some point you need to test it on a system level. So that's why, for example, here we have a strict separation for the low level and high level communication, for the power transfer, and also for further future extensions, such as the TLS security layer, which comes with ISO 15118. But the entire architecture is designed also to be future-proof, so that you can easily extend it when CharIN is ready to publish, let's say, the 2.0 and other future revisions of these conformance tests. Can we move on, please? Yeah, we can skip the verification loop for now. Okay, so next I would like to show you how this implementation looks like. So the first slide you see here is a match to the block diagram I just showed you before, but now with a little bit more details, because this is the actual way how we implemented it at Keysight. But instead of showing you block diagrams, let's take a look at the actual physical representation, which should follow on the next slide. Thank you. So on this slide, you can see 3 variants of our charging discovery system. On the very left, this is a specific variant for EMC tests. In the middle, there is a portable version which can be carried within the car to go to a permanently installed EVSE, for example. And on the very right, you can see a quite recent variant, which is a high power series. And this one allows to test EVSE and EV up to 600 amps and also up to 900 kilowatts. Next slide, please. Thank you. So these systems are designed to be operated in 3 use cases. As I said, you can test EVSE, but also EV. So when the CharIN certification program will be published for electric vehicles, you will be able to use the very same system. And also there is a 3rd use case for a man-in-the-middle analysis when connecting a car, like here on the 3rd picture, a car on the right and the charger on the left. You can kind of analyze the communication in between. But of course, in the scope of CharIN, we are now focusing in the next slides on this 2nd use case, which is showed on the bottom left. So to not only show still photos, I uploaded a short video clip, which is roughly 2 minutes. I hope we can run it now and I can tell you a little bit about what you will see.
Michael is on mute, I guess.
Actually, hello, do you hear me?
Yep.
Okay, so I was muted automatically and I didn't see it, sorry. So I was basically explaining the video to myself, sorry. Now we missed a few seconds, but what you could see before was the portable CDS attached to a DC charger. And now we are into the software. So what you can see here is, this is how a load dump test case is executed. The system is automatically recording all the relevant data. So of course you get a clear verdict on the left, which is passed in this case in green. But if it's necessary, you can actually use the trace anytime for post analysis in case there are some, let's say, observations or even causes which triggered a false verdict. This is very useful to then go into a post analysis. In this case, the load dump, I will explain it on an extra slide in very few minutes so that you understand what's happening. The whole execution just takes roughly 77 seconds and obviously is fully automated. Here, the 2nd sequence now shows a test project which has more than one. It has roughly 8 or 9 test cases. These are communication protocol test cases for the DIN spec. And here you can see it's very easy to export a PDF report, which provides a convenient summary of all the test results which have been obtained with one cycle. And finally, we can see here another example of a protocol test case, which I will present to you in the next slide. So this one is about slack link and the attenuation profile. So let's see if we can return to the slides. This looks good. Okay, great. All right, so in the next chapter, I would like to show you now a few test cases and, well, actually how these test cases can be executed on our test system and what kind of output you would expect, and explain you a little bit about the different flavors of test cases. Beat already mentioned a few, and I would like to use a few minutes to explain a little bit more about more depths to give you more context. Okay, so this test case attenuation characterization 019 is the one which you saw in the final sequence of the video. And let me explain briefly what it does. So basically it performs 2 consecutive charging attempts. And what really matters is just the beginning of the charging attempt, because when the slack link is performed, the test system here uses 2 different PLC modem power configurations, so that the first attempt is a regular one, and the second one we lower down the output power of the PLC modem of the test system in order to verify if the charging station after this execution is actually able to process the sounding files in the correct way and reply with the correct attenuation profile. And on this right screenshot, you can see that this worked perfectly fine here, as we have 2 distinct curves which are exactly separated by 10 dB as the test case demands. So this was a passed test case. The next one is called EVSE DC 20 charging attempts, and this one, well, I guess is self-explanatory. This one is meant for robustness. So as we have a sophisticated test system which is able to automate a lot of test sequences, here you simply start this test case, and the test case will go into charging and leave charging 20 times in a row. Of course, 20 is just a variable, so the test case, we decided to use 20 attempts, but of course, the user would be able to do 200 or 2000 charging attempts if it's for, let's say, more harsh internal testing. But for the conformance test, we decided on 20 charging attempts. And if you run this on our test system, you would then nicely see that here in terms of voltage, current, and power, and also PWM signal, you can greatly see how the charger successfully entered 20 charging sessions and also shut down each time in a correct way, which would result in a passed verdict. The next slide, thank you. Now, the next one is a little bit more sophisticated, but still one of the rather easy ones. First of all, you can see if you compare the voltage output here in the right screenshot, you can see that again, this is a loop. It's a loop with multiple charging attempts again. This test case is entirely focusing on the pre-charge phase. So what we do here is going through the lowest output voltage of the charger according to its data sheet and V2G messages, and looping with incremental steps up to the absolute maximum output voltage of the charger. And in every charging attempt, we are then measuring the actual voltage control accuracy of the charger and see if it performs within the tolerances. Next slide, please. Now, the TC25 performance check is again not only looking at the voltage, but actually at the entire operating points along the absolute maximum operating range of the charger. So on the right side, you see the a little element out of this test specification, and you see basically there is an operating point 2, 3, 4, and 5, and this is the outer boundary of the according EVSE specification. So you are having operating points at maximum voltage, at maximum current, and of course also along the maximum output power. And the test case, now on the next slide, we can see how the output would look like on our test system. Then is actually entering each operating point and then remaining in each operating point for a certain time. In this example, it was just a minute, but I think the final test case is holding each operating point for 5 minutes, I believe. So we are testing the robustness and stability, but also at the same time, it's verified if the EVSE is truly capable of actually running these absolute boundary operating points as it is stated in its data sheet. So here in this case, it worked fine. And the next test case goes even one step beyond, because if you imagine a regular charger being installed in some public site, it will typically only be connected to real cars right now. This is until we introduce this certification program. But how can you ensure that every charger will work fine even with future cars, which maybe are just announced and will be shipped in 6 months? Because future cars can have different voltage levels in their battery pack and even support higher current ratings. So in order to really test the entire test grid, you can see on the right side, we designed a test case here, which is called TC14, which checks the current control accuracy along the entire grid. So here you have really dozens operating points which are along the charger's specification. And each of these, I think in this case, it's actually 20 times 20. So it's like 400 dedicated operating points. And each of these will be verified for accuracy in terms of current control. So on the next slide, we can see how this output looks like. So here, first of all, worth to mention, you see, of course, a lot of steps by incremental steps on the upper part in current. Then there is an outer loop incrementing in the voltage, in this case, starting around 100 volts and finishing around 860 volts. And in this particular case, we had a maximum power of roughly 320 kilowatts. And this test takes roughly 2 hours and 5 minutes to be executed entirely. And of course, again, here you benefit from the automation from the test system. Let's move on, please. Now, this test case is the one you saw at the very beginning of the video. It's called load dump. And as the name says, basically it goes into charging. And once we reach stable operation, the test system disconnects the DC contactors and then measures the reaction of the EVSE. And if we go to the next slide, I would like to point out one interesting fact. So if you look here on the protocol sequence for DIN spec, which you would find in the DIN spec 7121 this way, the entire test case, oops, presentation lost. Thank you. So the actual test case objective to disconnect the power lines, the DC lines, is actually only one instant here, marked as number 5, as you can see here in the sequence diagram. Anything before and after that is actually regular charging. So why is that important? Well, I want to illustrate that the actual test sequence is quite simple. And if we please click one or twice so we see the full slide. Thank you. In order to get this result, you don't need to program like the entire charging sequence plus the disconnect. Instead, if we move on to the next slide, you can see that in order to execute this on our test system, please one more click. Thank you. This is the actual test sequence. So in the test sequence, it basically, you need just 3 steps. You first define the operating point, which you want to use. So at what current, at what voltage level you want to charge. Then one would wait for charging to be achieved within the sequence. Then in this case, we have 10 seconds of a timer to wait until we expect a stable operation with a desired charging current of 50 amps. And then there is simply one command, which is called open contactor, which allows to easily disconnect the DC line. And the rest is just measuring the output voltage and checking if the overshoot in this case, which is specified by 110%, is within the limits or not. This is an easy example. Of course, the test case is a little bit, includes more criteria to be tested, but I hope this shows you how the system operates. It runs the normal regular charging sequence by itself, and anything beyond that, any abnormal behavior within the test case is something the user would need to program itself. However, if you are looking at the CharIN conformance test cases, you simply can obtain all the test cases already being implemented and compiled from Keysight, so that you don't need to bother with programming if you don't want to. But this is still a very convenient way to modify test cases and create new test cases of your own. Next slide, please. Okay, so the next chapter is a brief example. I think we can skip that. It's a brief example of what did we learn while doing, as Voyun mentioned, we had different test events to run the different test systems and different test cases and compare results to really make sure that the results are consistent and that we have reproducible verdicts. And this slide shows you that if you compare the output voltage of 4 chargers in this case, you will get a very different behavior of the output voltage. So if we move on to the next slide, this is something let's say we didn't, or the test case designers had to incorporate these lessons learned into the test cases during this process, as it is not sufficient only design a test case on paper. You have a closed loop here, performing these tests, executing the test, and then applying the results back into the test case design in order to have really robust test case specification. And that's what I truly believe, that after multiple iterations, we have test cases now which are very thoughtful and will ensure reproducible results, even with all the different flavors of EVSE DC implementations out there. So for example, you see here the voltage output, as one would expect in the pre-charge, is not always a nice exponential curve or a rectangle curve. Instead, it goes up and down, and there is usually a control ripple, and there is quite a huge deviation which you need to consider in the test case design. But let's go to the next slide, please. Further, yeah, thank you. There are a lot of other effects which we learned during verification of these first implementations. So this one shows you what can happen if you have a high power DC charging station which has a cascade of power modules. Here in this EV target current, which is kind of purple or pink color here, you see the test system simply commanded a small incremental step from roughly 197 amps to 250 amps. And the orange curve is what the charging station actually delivered. And you see there is a big variation, and there's kind of a transient behavior in this very moment of increasing the current. And again, this is another example of things which you normally wouldn't have in mind when designing the test cases, but due to the many testivals and test events we performed over the last two and 3 years, we were able to address these kind of characteristics within the test case design and its implementation. Next slide, please. So here's another one. Again, the specification of the maximum power and maximum current of a charger is one thing, but whether or not the charger is actually capable of running this absolute limit operating points is another. Why? Again, as I told you, some chargers are already maxed out for future high power charging compatible cars, which partially don't really enter the market yet or are still limited in terms of charging power. And so if you really stress test that and you really go beyond the typical car characteristics, but actually until the very end of the specification of a charger, you sometimes see an unexpected behavior. And this screenshot shows you that in the maximum range of maximum power, this particular charger, when reaching 350 kilowatts, showed an kind of oscillation behavior. So of course, here is a lot of investigation going on whether or not this is related to the electronic load, as this one needs to be as close to the actual battery pack as possible, obviously. But I just wanted to share this example with you so that you get an idea how many iterations we went through before publishing these test cases. Next slide, please. So I would say we can skip that, as test case design now is mostly done. Of course, there will be a lot of redesigns, but I think we can skip that for now. And final slide. So in summary, I hope what you take away from today's seminar is that CharIN has published the 1.0 EVSE DC base specification for conformance test. And I hope that what you take from my presentation here is that Keysight is a partner and working in these working groups within CharIN with many other stakeholders, and we are able to provide an CCTS conform test system that is able to cover all of the test cases which we discussed today, and of course all the others which we couldn't discuss today. So please, if you are interested in our products or have any further questions, come back at me or visit our website. If you search for Charging Discover, you will find all the technical specification of the tools I just mentioned. Thank you very much.
Thank you so much, Michael. Really appreciate that. I think we have a Q&A, and yep, before that we have his poll questions. Yeah, so please answer this first, and then we do a Q&A. Okay, so welcome back. So we have some Q&A. Do we have any questions?
So yes, I put them in the chat window if you like, so you can see 3 questions to you.
Yeah. Okay, so the question number 1. That's question number 3. Let's see if I can
scroll up.
Yes. So the question number 1 is, will test certificates being which test
switch on your
are being
camera.
published?
Sorry, guys.
Sorry. What did you say, Ricardo?
I just said if it would be nice to have the cameras on from the moderators.
Okay, I thought my camera is on.
Yeah, your camera is on, but Michael and William.
Okay.
Yeah, we are still there.
Yeah, good. So everyone is still awake. I appreciate that. Okay, so which test certificates are being published on the CharIN website or DEKRA website with public access? Yeah, I think Ricardo, this is actually a CharIN question, so maybe this bounce back to you.
Yes. So yes, indeed. So we discussed about this, and we will have a section on the website where we will display the products which have gone through the process finally. So yeah, indeed.
Okay, thank you.
Yeah, maybe I can add on that. So in case, of course, when it is being tested at DEKRA, then DEKRA also does publish this on its website as well, no? In addition to CharIN.
Mm-hmm. Good.
Thank you. So then we have questions number 2, and that is what is our approach for vehicle or chargers that may support both 1518/2 and 1518/20. So that's both extended and advanced. Do you expect that some vehicles or chargers would support certain use cases with only 2 and others using 20, such as vehicle to X? And so on. So this is yeah. Yeah. So this is actually being discussed how we should handle this, and we I don't think we are fully there in the discussions yet. I'm not sure. Do you have any? Does any in the panel have any more to say about this issue?
Yeah, maybe I can add something. I mean, it's certainly and highly likely there will be cars on the market which, for example, only support, say, the DIN protocol. There will be cars on the market in the future which might only support ISO 15118, be it -2 or -20. If you look, let's say, 10, 15 years ahead, it's likely that there will be cars on the market which do support -20, but there also will be cars on the market which only support -2. So I think there will be a variety of cars on the market, and the same, of course, also would apply to charging station. So charging station also would have to go along with changing requirements with regards to the communication and be upgraded. But I guess for the next couple of years, in my opinion, there will be many of those standards still in use. So even the old DIN 7121 specification will be used for at least all these legacy cars.
Yes, and I agree with you, but I mean, we will have a diversification out on the market, and the main idea with this group is really to make the charging user experience as good as possible. So whatever is out there, we try to make it work, and we try to test it towards the standard to make sure that we have a smooth charging experience. Then, of course, there will be some time when the DIN standard may be changed for 1518, 2 and 20, but yeah, let's see when that happens, and then we also will have with the vehicle to X, there will be a diversification between different OEMs, but some will, for example, have vehicle to grid, other will have vehicle to house, or vehicle to load, or vehicle to vehicle. So I think the idea is to be able to test these different features.
Yeah.
So
exactly. And having said that, that of course also means, let's say, conformance and interoperability in the long term becomes even more important, because if you have many protocols which are being used, charger have to support many protocols, cars potentially have to support many protocols. So let's say conformance and interoperability testing becomes even more important in the future to ensure that all, let's say, EV users are happy or have this happy experience charging the car. Yeah.
And I think one really great thing with the development that has been within the group is that this automated conformance testing equipment, they are very versatile, and as shown here, you can really pinpoint what you would like to test. So for example, if you would like to test vehicle to load, then you can do that. If you want to test vehicle to grid and so on, so it can be chosen and it can be tested at every OEM, so if you have an EV EVSE manufacturer and so on.
So personally, maybe I can add, I think DIN-spec will remain being like the base implementation in most vehicles and chargers for quite some time. So I don't believe that there will be pure ISO implementations without DIN support. At least I haven't seen it yet. And I think that CharIN will kind of define like the minimum use case and feature subsets which need to be supported by, like, for this extended and advanced charging. And this will probably help and prevent a little bit like a complete mess to have like 20 different variations of protocols and cross protocols and different editions of protocols, because then the OEMs can focus on certain, let's say, fundamental implementations you definitely need, plus maybe some value-added services which are optional. And just maybe to comment on what this means for the test device. Indeed, as Johan said, the test systems are designed in a very modular way, so it is easy to run ISO 15118 test case on it without changing the hardware. It's also already future-proof for -20 and reverse power transfer, as the electronic loads and sources, at least the ones from Keysight, are bi-directional. You can test this use case in the future without the need of changing your test setup.
Thank you so much, Michael. Moving on to question 3. How long will the full test sequence take with a Keysight tester? So I guess it's back to you, Michael.
I would pass this question to Beat because he maybe now run a lot of these tests in his lab and performs the test as they are intended. So I could guess, but I think Beat and Boyun could answer this better.
I think the complete set of requirements as we have it now, based on the DC EVSE basic 1.1.5, it takes about a week to run through the complete testing. That of course always assumes that you are not encountering major fails.
Yes, as we have the very similar experience, it takes a week for one round.
Okay, great. Thank you so much. So then to the question number 4, does CCS cases include EV ready and CE ready cases, SATE ready cases? Can anyone?
Yeah, maybe I can try to answer that. So EV ready at the moment is only for AC charging. EV ready does have some requirements in terms of control pilot, but the current CCS DC EV EVSE, as said, is for DC. So that basically means it does not actually include what is needed for EV ready and SATE ready certification. There is a working group working on AC, and that, let's say, future AC requirements will have a bit more of the EV ready requirements and ZE ready requirements included, but it will also not be a complete, let's say, set of requirements coming from there.
One additional note from my side, as far as I know, this Alice from the Luno is actively participating to develop the specification of their CCS basic EVSE AC. So if we have some finalized specification on that, this might be the EV ready and the GE ready. Some of the AC charger test cases could be included, but I'm not the active member of the AC specification development team, so I'm not sure, but that's, I guess, some of the test cases could be migrated from the GE ready or the EV ready into there.
Thank you so much. Yeah, so not shown in the presentation, but we also have an AC team that are working with these questions. So I think that is as good as we can answer here now, but if whoever sent that question, please give us the email and we can talk with the AC team and come back with more details. The last questions in the chat, at least, is, for example, if a charger is certified with a set of power modules and the power module changes, but the rest of the charger is the same, does that indicate need for recertification?
Maybe I can give here, let's say, an opinion. I think Michael has actually shown before that there are indeed differences when you look at the power modules. So he has shown a nice slide where you could see that the power module did do something, let's say, strange, if I may say it so. So changing power modules basically would indicate that there is a need for recertification. It is, let's say, depending on what are actually the differences to decide which kind of testing has to be redone. But just changing power modules without retesting and potentially recertification, that will not be possible.
So yeah, just to dig a little bit deep in that question, is it EMC that we're worried about, or is it actually how we control the current, or what is the main reason that we need?
Yeah, I mean, of course, it has several aspects. I mean, you have to look from a safety aspect, you have to look from an EMC aspect, and we also look at an interoperability. And as a matter of fact, when you talk about changing power modules by a new power modules, then you are automatically going to have a safety impact. And of course, you potentially have an EMC impact. Now, from the interoperability perspective, if you look at how this interoperability does impact, then based on the slides which has been shown by Michael, for example, we have seen this oscillation from the power modules when they are operated at, let's say, at the highest operating point. Or we also have seen that when you have these cascaded power modules, that sometimes they start to, flip back and forth. So changing power modules will have an impact also on interoperability testing, not on all of the test cases, but on some of the test cases. And of course, it definitely will have an impact on EMC and, for example, electrical safety.
Okay, thank you very much, Beat. That was very clear. Yes, it's needed. And thank you so much for elaborating on that. That was the last question for today. I want to thank all of you who called in and joined us. And please feel free to join the group and be part of this very exciting development and actually being the pioneers making a working charging infrastructure for globally. Thank you so much for today.